Thank you for joining. This is John Driscoll with Boston Engineering, General Sales Manager, and own the relationship both with Parametric Technology Corporation as well as Ansys. Excited to have you guys on this afternoon. Have about 30 minutes and really do appreciate you spending your time with us. Terry Robbins, one of our senior application engineers, will be delivering the demonstration, and Jim Shaw, our subject matter expert, simulation resource, will be available up towards the end, and we'll be answering questions and answers as they come up. So do encourage you to submit questions along the way in the area to submit those, and we'll cover those towards the end. So thank you again for joining. A little bit about Boston Engineering. We're a product development consulting organization that help companies from innovation through conceptual design to commercializing their products, and really excited to play a role in the Ansys PTC simulation aspect. From a PTC perspective and an Ansys, do have the ability to leverage a lot of their technology in incorporating that into the design process and getting the efficiency gains that we can get from integral solutions. And now with the partnership with Ansys and PTC, excited for that as well. We build credibility in the sense that we work in defense and security, industrial, commercial, medical, so do have certifications, as well as a presence in Massachusetts, as we are a Waltham, Massachusetts-based company. As an 80-person company, about 75% of them being engineers. We do put a lot of emphasis on our centers of excellence, so a lot of domain expertise in these different areas. And as you can imagine, simulation plays a critical role in all of these areas as we're looking to simulate more and more these days, as it's becoming more costly to build prototypes and things of that nature. At a very high level, the agenda, Terry's going to walk through the structural capabilities of Creo Simulation Live. There are thermal and modal capabilities, and we might have some follow-on opportunities, but if you would like to afterwards, feel free to reach out to us and we can absolutely demonstrate or talk through those capabilities as well. And towards the end, as we noted, Jim will be covering some of the technical questions that come up throughout the process. Some of you may or may not be aware, but a couple of years now, PTC became more integral and more of a strategic relationship with Ansys. They've gone ahead and really kind of prioritize their simulation strategy around Ansys and using that capability inside of Creo. So this Creo Simulation Live is the first solution that they co-developed, taking advantage of some of the GPU capabilities, and really excited about it. But there is more to come, and the partnership is definitely maturing and will be evolving over the next 5-10 years. And as a solutions partner for both PTC and now Ansys, we felt it was critical for us to understand the capabilities and solutions that both software vendors provide and the value they bring to their customers like yourselves. Why Creo Simulation Live? Many of you are designers on the call and really are looking for more kind of upfront capabilities in the design process. So, rapidly be able to design and develop, make better decisions, obviously use simulation and some of that analysis to make those decisions. Prototypes, the reliance on those, the physical costs to make those, and obviously providing better products and improving quality for downstream is ultimately very important as well. What it'll give you for real-time feedback, very intuitive, easy to use application, gives you structural thermal modal capabilities, give you the ability to simulate, animate these things, see them real time, which you'll be able to see as Terry delivers a demonstration. And most importantly, it's embedded integral within Creo environment, but it is leveraging the Ansys simulation technology and power that it provides. I'll just build this slide out at a high level. As you can see here, some of the simulation animations, some of the still photos, but Van Mises stresses and the things that you should expect from a simulation solution capability are part of this Creo Simulation Live capability. Allow you to do power linear solving, the meshing capabilities. It shows up as a tab within the Creo environment. So as many of you are designers using Creo today, to digitally design your products, you want to be able to seamlessly, design your parts, assemblies, models, and go very quickly into Simulate, and then get those results real time. So not having to export out or jump into another application or save files. So obviously from an efficiency, speed, it's critical that it's a tab within the Creo parametric application. I do want to highlight that there are some links here. So hopefully many of you have PTC support accounts created. And this link that we'll be able to provide, you can get a ton of frequently asked questions on Creo Simulation Live. And then it is important as well from a hardware perspective that it does have some requirements that you want to make sure you have certified graphics cards to run Creo Simulation Live, and make sure you include that as part of the selection process, or if you do move forward and purchase the software from Boston Engineering or somebody else, that you take that into account, since it is important from a performance standpoint, and just making sure that you're getting the results that you're expecting. As noted before, Creo Simulation Live is that first solution that PTC and Ansys have brought to the market. It's been well received. We have a number of customers using it in production today, and being able to use the simulations and correlating it back to test data. And so from an accuracy, trust perspective, they definitely see the benefits of it, and it's really bringing that simulation more upfront into the design space, as opposed to maybe some of the more expansive PhD type solutions that Ansys provides, whereas many of our customers that are using Ansys, and we're supporting them with that, this is kind of more purpose built for that mechanical engineer designer aspect of it. And Creo Simulation AIM will be coming out. As you know, many of you, Creo 7 will be coming out in a few weeks. Excited about that, and PTC will have some new capabilities, extensions that will be available as well as they continue to deliver more technology. And PTC's strategy on simulation is Ansys, so obviously excited about that, more to come. So without further ado, I will transition over to Terry Robbins, who will deliver the Creo Simulation Live presentation today. And thank you for your time, and thank you for joining.
Thank you, John. Very good. So as you can look here on my screen, excuse me, let me make sure I've got it maximized out here so we don't have to worry about it. We have a snowmobile. Those of us who live in the northern reaches of the world see this quite often. This is the Polaris snowmobile out of Rousseau, Minnesota. We're going to actually go in and we're going to take a look at the chassis subassembly, and mainly we're going to take a look at this sheet metal bracket. We're curious as to what happens if we apply a load on the top of this sheet metal bracket. Now, typically you would do that with an analysis package, whether it be Creo Simulate or whether it be Ansys, and you would go in and you would have to mesh this model and apply materials, loads, constraints, those type things. But what I'm going to do is show you how Creo Simulate Live is going to put that power of an analysis into the designer's hands so that he can assist the true, as John said, PhD analyst that's out there doing the full-blown analysis. This is not in any way meant to replace any analysis, but this does give you the ability to do what-if scenarios very quickly, as opposed to making a design change, running an analysis. Oh, I don't like that, undo it, make a new change, do another analysis, which takes time and effort. So I'm going to open this. This is just a standard sheet metal part created within Creo. So here it is. The material for this part was set up in the part preparation, so it already has a material assigned to it. As John mentioned, we have a live simulation tab in our dashboard, so we will click on it. And when we click on it, that in essence takes us into our Creo Simulate Live functionality. So now, if I expand this structure here, notice we're looking for loads and constraints. So we need to constrain and load this model in such a way that we can get an analysis. So if I click on constraints, I want to go and I want to hold this model the same way it was held earlier. So it had 2 bolts holding it in at these locations. So we'll go in and we'll fix those. And if I expand my constraints tab, you can see that I have my fixed constraints. Now we want to apply a load to this surface. So we click on loads, go in here and we create a force, select the surface. In our lower right corner, we have a coordinate system that tells us what our part, our analysis part coordinate system is. So I want in the Y direction, I want to go in the negative direction. So I'm going to go minus 120. And you also have the ability to set units here. So we're going to set that to be newtons. And we say, okay. So now we have our part that's set out there. It is material specified. The constraints are fixed. The loads are applied. All I have to do is come up and click on the simulate engine, and in a matter of about 10 seconds, I have an analysis result, and I have a legend over here that's showing me my von Mises stresses in megapascals. So I have a maximum of 126 megapascals. So I'm gonna spin this model around just a little bit. A couple of things that we can derive from this model, and then I'll make a couple of changes, is if I go into my results options, I can actually go in and play and hit the little play button, and we can actually see how that model is going to deform. Now, you have a speed button here that you can slide so that you can, dictate how fast you want it to move. You may have something that only moves a few thousandths, which is very difficult to see. You may see the color bands changing, but you really don't know how it's moving. You can actually go in and increase the scale. Now, this does not change the amount. It just exaggerates it so you can see it visually. And we'll pull that back. We can actually do a true deformation, and you can see how much it would move truly in real life. I'll stop that, go into our results. Currently, I'm looking at von Mises stress. I could go in and say I wanted to look at a deformation. Well, look, out here, it's moving the most out here, which is the furthest away from our pivot point, which is what we would expect as designers or engineers. I'm going to take this back to von Mises stress. I'm going to change the units to megapascals. Notice we have a button here that says show min max. We have two circles. We have a circle right here. Then this is the maximum value for this particular model. And then down here at the bottom, as far away from it, would be our minimum. We can turn that on or off and show it at will. So let's go and make a couple of changes so that you can see what happens here. So we can take our simulation probe functionality, which is one of our query tools, and we can query, and I can say, come in, and I want to see the maximum stress, and I want to see it on this surface. And notice it gives me a value. It gives me the value in a little box here. It's 125.5 megapascals. I want to save this. And the reason I'm saving this is so you can follow along and I don't have to recreate it every single time. So I have saved that. Now, if you notice, you have distinct color bands. I can come over into the model tree. I can click on my legend at the bottom, and it'll give me a blended color band as opposed to the distinct lines. That is a personal preference that does not change any of the analysis or any of the values. So the first thing we want to do is let's go and move and make this part just a little bit longer. So I want to come in, I want to add some length to this end. So I'm going to select this surface, this surface, this surface, this surface, those surfaces. I'm going to go into my flexible modeling tool, and I'm going to say I want to move those. And I want to move those along this edge, and I start dragging it to get a number, and I'm going to change this number to about 14 units. And I hit my OK button. Notice it changes the geometry. I've got a little new tangent here. And after it recalculates, it changes my stress. My stress was 125. Now it's down to 117. So we can make those changes, and you can see those happen immediately. One of the things we have here is we have sharp corners. And sharp corners, stress concentrations aren't good. So let's go into the bend, and we're going to edit the definition of that bend, and we're going to go into our bend relief, and we're going to change those from a rectangular bend to an ob round bend, and we'll accept those, and it will regenerate our model. Then it will regenerate our analysis, and it will change a little bit. Now we're changed down to 107. Now the last change I'm going to make, is this hole in the original model was there to remove weight. There's no wires going through it. There's no bolts or anything holding it together. It was there strictly to reduce weight. So I'm going to go into our flexible modeling. I'm going to highlight it, and I'm going to recognize that as a complete hole. And we're going to remove that hole, and we'll complete our feature. And when we complete our feature, and it has a chance to go in and regenerate the entire model and everything, notice that we have taken our model from the 125 that it was at initially down to 104. And it happens that fast. in a matter of less than 5 minutes, I have made 3 or 4 changes to this model. I've lengthened it, I've removed holes, I've done this, and these changes that I have made are parametric. So as you make those changes, they update. If I were to go in and change the material, the values would change based on the material properties that we have and the like. So
Hi, Terry, did we lose audio? Can't hear you.
I'm turning this over to Jim. Jim, are you there?
Yes. All right. Well, thank you, Terry. Yep. Sorry about that. We'll have to clip that out. Right, Terry just showed us a really perfect prime example of applying Creo Simulate Live. The whole purpose here is to provide a tool to help a designer, guide them down the path, right? Traditional FEA like Creo Simulate and some of the Ansys products, that's a more thorough, if you will, finite element analysis tool. So we're going to be a little bit more, time consuming when it comes to meshing, mesh dependence, independence, post processing, and digging in and interrogating the model. And what Ansys has found in Creo, what they've discovered is there's a huge need for a tool that's going to be nice and quick, help guide us towards, hey, what's going to make our part stiffer, what's going to make our part lighter without making it any weaker or less reliable. And it's okay if, for example, the stresses aren't going to match to test data within 1%. There's still certainly a lot of value in using stress analysis as a quantitative decision-making tool. So Terry, great job. That's a prime example. He made 3 or 4 changes. We're able to go from 125 MPa down to 104. Now, you go to run tests, you throw a strain gauge on, it may not be 104, but the trends that we see in the changes that he made are certainly going to hold true, because what we're doing underneath the hood is we're still solving stress analysis. That's a great, perfect example. My favorite part is, number 1, of course, you're embedded in Creo, and then number 2, just the sheer speed. You don't have to go back and forth meshing and sort of dealing with all that. It's all live. You spend more time, in the model tree adding features and playing around with the geometry. So with that, let me just see. We do have a couple questions over here on in our chat box here. The first question is about the materials. And so Terry, we still have control of the mouse, right? Yeah, why don't we go up to File, Prepare, and we'll just show model property. So I think it was a couple of years ago. We'll hit Change, and then everyone will notice that sort of legacy material folder that we have in there. That's all the classic original Pro Engineer materials or Pro Mechanica materials from way back in the day. But next to that, parallel to that, is a standards material grant to design. This is a really deep material library that Granta has partnered with both Creo and with Ansys to provide a lot of precise material definition. So deeper bench here, a little bit less homework. You still need to do some homework. There's a comment here, it looks like from Gavin, about linear. Yeah, so John in the beginning had mentioned, one of the purposes of this tool is a real quick tool, and as a result, it's not a full-blown, non-linear, full dynamic, FEA solver. It's really focused on linear, statics, modal analysis, and thermal. And Terry showed us a linear static analysis. So we really don't need a lot of material properties for linear static analysis. All we need are the Poisson's ratio and the Young's modulus. So, and then of course, yeah, exactly. You can always go to MatWeb and download and plug those in. Yeah, so the next Creo 7 is going to come out with CSL. It's also going to include some of the fluid analysis tools. And again, it's not going to be a full-blown CFD solver like we're used to with either Sumerix or Ansys Fluent. it's going to be a further sort of a lighter weight tool that you can dynamically change and automatically update, air and water flow. So that's really neat stuff. Looking forward to that. Terry, we'll do another one when the fluid comes out, right?
That is correct. We'll do another one when the fluid comes out.
All right, excellent. Let's see. So question here about contact. And again, so, your thorough contact analysis, we want friction, we want relative motion, so that all that is nonlinear. And so right now, the only management of contact for Creo Simulate Live is a bonded representation, which again, if we just assume for a quick second, I've got all my bolts are torqued, my rivets are properly inserted, everything there's no relative motion at the joint, then we can still absolutely use CSL as a tool to make some design changes up front conceptually. If it is really critical that you get the proper stresses at a bolted joint or at a fastener or at the interface of two parts, then at that point you'll go into Creo Simulate and do a nonlinear frictional analysis, or you go into Ansys or your FEA tool of choice. So yeah, for now, the focus on CSL is to keep it up front, keep it quick. That's one of the other benefits we get of keeping it linear, keep it nice and quick. Let's see what else we have here. So so someone's asking, so can you specify a deformation in addition to a force? Yeah, Terry, why don't we close down the materials window there, and we'll just go back to that the live simulation tab and just take a peek at what all of our options are. So if we go over to live simulation up top, we'll be able to see, so underneath the constraints, we've got fixed and we've got displacement. So that's where we can set a certain displacement. We've got frictionless, which is kind of like a planar type constraint. And on the load side, we have, I would say, 5 of the most popular loads, right? We've got force and moment, and then we've got pressure, gravity, and centrifugal. So we've got a combination there of forces and accelerations. I would say that, for those combination of 5 loads and 3 constraints, you're probably capturing, 75% of, a quick linear FEA, what you're trying to do. So, and who knows? Ansys is always going to be, developing the capabilities of the tool as the customers send in requests, and for sure, we Creo users are going to take advantage of that. So I would say, I'm not going to put any words in anyone's mouth, but I would be I wouldn't be surprised if we started to see a little bit more functionality based on how people are using it and giving feedback to both Creo and Ansys. Let's see. So we got a question here on what's the difference between the Creo Simulate Live and the analysis tab. So Terry, if you want to click on, well, if you've got applications, or the analysis tab to the left, I think is just some tolerance analysis and tools. But there's also a button for simulate analysis, but it's also the same as the application for simulate. So that is the, the thorough finite element analysis, the traditional mesh tool that most of us have probably been using for some time. You're going to have a lot more options in regards to loads and constraints. There's a lot more options in regards to physics. So you've got thermal, you've got stresses, you've got nonlinear, you've got frictional contact, you've got full dynamics, you've got thermal stress, so a little bit of multi-physics there. So really, when it comes time to do the more advanced analysis, and when it comes time to do maybe something more accurate, when I say accurate, I mean a tool that allows you to throw options in when you are at the point where I've got test data, I've got finite element analysis results, and there's a disconnect, and I need to dig into the FEA and find out why it's not matching the test. Your full-blown FEA solver like Creo Simulate or Ansys AIM is going to do that for you. CSL is not meant to do that. Now, it doesn't mean CSL won't give you an accurate answer. If you're simulating something that's linear, so relatively small deflections, relatively simple geometry, apart, and there's no reason why you can't get test data that's going to match up to the CSL, but it's just not exactly designed for that. And so again, I think that the way this is deployed, and we have a question here on what have we seen from companies that are using this, and so where we've seen it, and the answer to that is yes, it's been deployed, and yes, it's being used successfully. And so we've actually got a customer who we were just talking to. They've got a larger team. They've got a team large enough where they've got quote unquote designers and quote unquote analysts, whatever that means, and they've got full blown Ansys. And so obviously, you know, that is their FEA de facto tool when they want to go all the way down, you know, sort of the rabbit hole, if you will, in stress analysis and FEA and connecting some of the simulation results to test data. But there are a dozen designers in their organization that still, they're by all means wanting to use finite element analysis. It doesn't make a lot of sense for that team to purchase a dozen licenses of Ansys. I'm sure the salespeople would want that, but from an engineering standpoint, you know, everything's budget related, of course, that doesn't really make a lot of sense. And so where we see this being used absolutely successfully right now is deploying that to the design team so that they can vet designs up front, right? So, you know, the Ansys team, if you will, they're always going to be busy. They're always going to have a backlog or a queue. And, you know, if a designer can use finite element analysis, come up with, say, an 80 or 90% optimized design, and then hand it over to the quote unquote dedicated FEA analyst team. Number one, you're going to make their job a lot easier. Number two, you're going to be a better designer. Number three, you're going to end up getting parts out the door faster, and that really helps everybody. So that is how it's being used. And again, it all depends on the size of your organization and the titles and the responsibility overlap there. But you know, there's a great example of how we're seeing this deployed right now. And then I think that's it. Yeah, we do have, there's a question here from Otto. You know, I have a flat spring and I want to bend 2 millimeters and see if my part can handle the stress. You know, that's a great use case. I've got some geometry. I want to put a load on it, constrain it, bend it, and see what happens. A flat spring is usually, and again, I don't know what the geometry looks like, but typically flat springs are long and skinny. So that means they have an aspect ratio that's greater than 10:1. So, you know, its size is more than 10 times more than its thickness. And for those types of geometry problems, we typically say that they're going to be a nonlinear analysis. And so absolutely, you can model it up, you can throw a hole on it, constrain it, put a load on it in CSL, get a deflection that is on its way towards being accurate. And as a designer, you might be able to tune the design of that flat spring, but ultimately you're going to want to put a nonlinear environment like that into a full-blown FEA tool like Creo Simulator, Ansys AIM, and make sure that you're getting accurate stresses. And again, it all depends on, you know, how precise do the parts need to be? What's that window of optimization that you're going for? You know, if it's going to be on a plane or a car, and you're worried about, you know, exactly how many cycles of fatigue this can handle before the warranty, you know, is up, things like that. FEA is probably going to be a critical part of the process that you're going to be using after you use CSL up front for the design. So let's see, I think that covers all of the questions. Yeah, so that's all that I have. I think we covered everything. John gave a great, you know, pitch on the business case and why it's useful. Terry, thank you very much for the hands-on stuff, and look forward to staying in touch with everybody and hopefully get some CSL in your hands and hear some feedback and hopefully become the tool you guys can use.
Thanks, Jim. So again, just obviously Boston Engineering is a product development consulting company. We have the ability and the unique ability, I should say, to position and understand your simulation requirements. Please feel free to reach out to us. We engage with customers on simulation projects that they might potentially outsource. And then there's also projects where we could provide you with the software and training and kind of help drive adoption. And if you're a customer that's using PTC simulation tools and Ansys simulation tools, from an adoption maturity standpoint, we've engaged with numbers of companies that have been very successful in understanding kind of when and where to use the different technologies in the product development process. So please reach out to us and happy to engage at whatever level you guys might be at. And thank you for taking your time to spend with us for 30 minutes today. We'll have this recorded, we'll send it out, it'll be posted on our website. And as Jim noted, we'll have some more coming in the near future. So appreciate it, enjoy the rest of your day and have a wonderful day.
Thanks, John. Thanks, everybody.